we have this amplifier. So nu3000, that's the model number. And that's how the back look like.
Guinness Saliva of the Czech
2006. Anyway, the customer told me he has a problem in the wires, speaker wires. They were shorted. Let me clean it a little bit. You can see how much dust it has. When I was testing the device, I found these two here, and they blow like, you can see how it's there. And it's blow some little component here. This is a transistor here. There is a little hole in this resistor. It was a diode here. And so this is the component that's connected to the gate of these two MOSFETs here. The gate of that two MOSFET is connected to this IC. So this IC sends the signal to this little transformer, because there is an input here, these two wires, and there is the output here, the two wires. So that's good. This coil here, like dividing the high voltage part with the gate of the MOSFET. So dividing the chip from the gate of the MOSFET. Anything happen to the chip, it's not going to affect the MOSFET or the MOSFET side, or anything happen in the MOSFET side is not affect the chip. So that's what it's was good for. The output of this IC is just giving one output. So there is two wires here for that output. In this side, that output is become like a 4 wires. So there is one here and one here. There is one, then there is the other one is here. That's going to these two MOSFETs. So this coil, this little transformer is making the signal like divide to the two output. So on this diode there is no short. Yeah, there is a short in this IC, in this transistor. And this is a low ohm resistor. So let's check the diode for reading. So this diode this way is giving me no reading. This way I do have reading 0.200 volt. So this one here is shorted, and we need to figure out what that one is. Let's see. So 2T4, and the diode is B4. So you can see where that blown. Oh, this resistor here is bad. So we need this stuff here. Then we're going to, after we install this bad component, we're going to check in the gate of the MOSFETs if we have the signal. Then we replace these two MOSFETs here. This is all in the power section now. After we fix the power section, then we go to the amplifiers IC here. And we're going to go to the marking SMD. So the first one, it was 2T. So number 2 is here, and we go to the letter T where it's here, the PNP. So this is a PNP transistor. So we're gonna need one of the transistors, and we go look for the other one is the B4, the diode. So it's the Zener diode. Some of them it's this Schottky diode. Yeah, so between Zener diode and Schottky diode. So we're gonna need the two rectifier diode, fast switching diode, and we need the two PNP transistor. So the switching diode should be like 40 volt or more, and transistor I think is about 60 volt or more. So this is the transistor we took out. Is a PNP, so this transistor is good. So I'm just going to test the diode and test the other transistor. So two transistor tested good, and this is the diode. It tests good as well. So I test one more diode, then we start putting them in the board. So we're going to measure with the oscilloscope. We're going to measure, put the ground here, and we measure if we see if we have the square wave here. Then the same and the other MOSFET, we put the ground here, and we test here to see if we have a square wave. If we have the square wave coming to here, it's mean coming to the gate. It's mean if we put the transistor over there, it's going to start cutting the voltage to this transformer here, TR2, to this little transformer here. And it's go to the TR4. TR4, it's here. This is the big transformer, TR4. So we're going to measure here between, this is going to be our ground for oscilloscope, and this is the gauge. And here is going to be, this is the ground, and this is the gauge. We can't use the ground from any of here, because that's not the real ground. As you see here, you see this part here, this coil here, look. From here, we don't have connected to the ground. So if we measure from here, and we put the square wave here, we're going to measure all with this MOSFET, and we may not have the square wave. So we need to measure between this point and this point here to be sure that the square wave pass all these components to reach the MOSFET. Same thing here, we're going to measure between this point to this point, or between this resistor 10 kilo ohm. So I'm just going to measure between these big pads here, is more easy. Ground and test, ground and test. At the same time, we're going to look at the oscilloscope. See if I can do both of them. Yeah, the oscilloscope right over there. If we see the square wave, it means it's good. So I just connect the multimeter probe to the ground. It's going to be more easy for me. So we turn it on. The device is on, and let's measure. Yeah, you see the square wave? Yeah, we have a square wave. Yeah, the square wave gone. And let's test to the other MOSFET. The square wave is over there. So now if we put the MOSFET, it should be start cutting. Yeah, this doesn't look promising. It's look fake. This is the China stuff. So we need to cut this leg, and we're going to bend the other leg. So we cut the middle one, and we bend that one to fit. So it's the same part number. It's just not, you know how is the China components. The problem, there is nowhere to order the stuff from US. Or most of them, like the newer devices, yeah, you can find them in DGK or other websites. But from the old ones, usually just China have them. They don't make them anymore. So here. The legs are bent.
the chip. We need a big chip to solder that to the heatsink. So that is 190 minus 15 is 4. Yeah. So it's true. It's true, okay. Because they're the same number. 49 divided by 9. 45 divided by 9 is 5. Yes, that 45 divided by 9 is 5. Okay. What is this? 5, 45 divided by 9 is 5. Yes. Now, 2 times 3, 6. So 6 minus 4. So 6, 2 times 3 is 6. You see here says 2 times 3 minus 1. So 2 times 3 is 6, then I minus 1 equals 5. Mm-hmm. So is that right? Let me see. 2 times 3 is 6, then I minus 1 is 5. Yep. You see it's true. Yep. Because they're the same number. So 3 times 3 is 9. 3 times 3 is 9. Yes. So
Yeah, when I was looking in the DGK for this component, yeah, I find the transistor, a compatible transistor to this one, but they want me to buy like, I think it's a 9,900 something. They don't allow to sell like 10 or 20 or so. What I'm gonna do with 9,000? So this small component, usually DGK, they don't sell like by the 10 or even 50 components. No, they just sell like 1,000 or 10,000 one. 10,000 of this transistor, and they are about like 50 cents each. So it's about like $5,000 just to fix this device.
is 8.
Okay, so we cover our work in case if it's explode. You know, you don't want this stuff to explode to your eye. So yeah, I plug the power. Yeah, the device turns on. I hear the fan. Okay, let's do it. You see the fan? Let's do it again. Yeah, the fan is go on. Nothing explode. That's good.